is Nicolas Chuberre from Thales Alenia Space, and I've been working on the radio communications over the last 30 years, and recently been working on satellite systems in the context of 5G and 6G, and as such I have been doing some work in 3GPP on what is called the non-terrestrial networks, which encompass satellite as well as HAPS-based networks. There are three main scenarios targeted. The first is to enable a satellite network to serve some mass market IoT devices, just as you have already IoT devices that can be served by mobile network with the narrowband IoT or eMTC access technologies. The second is to be able to provide direct connectivity from satellite to smartphones. So the commercial smartphones, and that's really a disruption because satellite networks are not very well known to provide to be able to serve the mass market apart from broadcast. And the third scenario is to improve the connectivity to hotspot, some access point that would be deployed in business premises or in remote areas or on board moving platforms like train, vessels or airplanes that may encounter areas where there is no mobile coverage and the satellite can provide the relay. So in all cases, the satellite role is going to be to extend the coverage of the mobile networks, or to provide some kind of to improve the service availability in case there is a failure on the mobile network. And NTN is actually providing some features that are going to mitigate the specifics of satellite networks compared to mobile network. And the main difference between a satellite and a mobile network is you have a higher latency because the satellite altitude may go up to 36,000 kilometers, and that would create a latency of up to half a second, which is to be compared to a few milliseconds with a latency within a terrestrial network. You have higher Doppler, especially if the satellite is moving around the Earth. And this Doppler is larger, but also it can be variable. The radio cells generated from satellite can reach up to several hundred kilometers diameter. This is to be compared with a terrestrial network that has a maximum range of tens of kilometers. And then you have this service continuity between a terrestrial network to the non-terrestrial network and vice versa, which is a new challenge because you want to try to offer a seamless service continuity. There are other issues, but these are the main ones that we need to tackle and to mitigate with some new features or updated features that are within the 5G system. NTN is a standard which is published, but also that includes some interoperability tests between network and user equipment. we don't have such kind of standard in the satellite communication, especially for providing broadband or even narrowband services. All the satellite networks so far are proprietary. So as such, each vendor is providing not only the network infrastructure, but also the terminal. And so if you have like a terminal that operates over a satellite network, it will not operate over another satellite network. So it prevents the global circulation of devices, but also of equipment. So this multi-vendor interoperability associated to the standard is something which is all SATCOM users are interested in, because they want to escape from the current vendor lock. The second point is that, well, if you consider what are the user equipment of any telecom network, well, it can be a smartphone, it can be a tablet, it can be a PC, well, it could be a plain text telephone for your grandma. But I mean, these are devices that all operate with mobile network. So a satellite network has, if you want, I mean, you have to fit into there and provide a service in the overall mobile network. If you want to leverage the satellite services, because currently satellite network designed only to address a specific type of terminals, they are very restricted in terms of market share. So it is very important to be able to integrate seamlessly satellite component in the 5G system. And users are calling for satellite network that can be combined with a mobile network, so that you can move, for instance, if you're on a vessel, you will move from terrestrial network to the satellite network seamlessly. You can also consider to combine geostationary based satellite network together with non-geostationary satellite network. The first providing capacity and the second providing low latency, so you can play around and maximize the quality of service and the throughput for the users. And of course, if you are going to deploy NTN standard in your future satellite communication systems, you will be able to support natively some 5G features like the slicing, the security, the QoS management, and also energy saving, because that's something which is becoming more and more crucial, even in satellite networks where most of the energy is being consumed by the user terminals. DYNASAT has considered some constellation of satellite to provide connectivity to smartphones or to IoT devices, and we are looking in techniques that would improve the throughput, so that overall the network can I would say maximize the capacity it can offer to the users, implementing some technologies that would exploit the satellite diversity. And the second is to explore how satellite network could coexist with a mobile network in the same band, in the same frequency band. So all the issues associated to the spectrum sharing we have investigated. So these are two main objectives that we're following in the DYNASAT project.